Okay, following on from my previous video, we're going to be looking at using the method of differences to find the value of this series in terms of n. So first of all, notice that this question is not split up into parts. So first of all, we need to use partial fractions on this fraction to split it up. So 1 over 3r plus 4 times 3r plus 1 is somehow identical to something over 3r plus 4 plus something else over 3r plus 1. Multiply everything by the left-hand side denominator. Gives me this. And now I can equate the coefficients. So a must equal minus b. Looking at the coefficients of r, I get 3a plus 3b is 0, so a must equal minus b. Looking at the constants, I'll get a plus 4b must equal 1. So therefore b equals a third. And a must equal minus a third. There we go. So therefore the sum, I'm just going to take the third out just because I don't need it. Kicking around, it's going to get in my way. It goes from r is 0 this time, not r is 1. Just make sure you are paying attention as to what the question is asking. B was positive, so it's going to be 1 over 3r plus 1. And then it's a was negative, so that's going to be 1 over 3r plus 4. And this series is of the form f of r minus f of r plus 1, as we had before. So plug in r is 0, okay, taking the third out. R is 0, that's going to be 1 over 1 minus 1 over 4. Sorry, 1 over 4. Plug in r is 1, we'll get 1 over 4 minus 1 over 7. Plug in r is 2, we'll get plus 1 over 7 minus 1 over 10. Pattern continues. Plug in r is n minus 1. We'll get 1 over 3n minus 2 plus 1 over 3n plus 1. Plug in r is n. We'll get there's a minus there. Plus 1 over 3n plus 1 minus 1 over 3n plus 4. And all of that is times by the third, which is still kicking around at the front. So the quarters cancel, the sevenths cancel, the tenth will cancel, that will cancel one before it, that cancels, and we're left with the first term and the last term, just as before. So therefore this series is equal to a third into 1 minus 1 over 3n plus 4, which equals a third into 3n plus 4 minus 1 over 3n plus 4, which is 3n plus 3 over 3n plus 4 times a third. And now, because the top, both multiples are 3, I can say that's n plus 1 over 3n plus 4. And that is my answer. As n tends to infinity, the series S will tend to a third in this case. Look at the coefficients. Okay, as n tends to infinity, these constants will become negligible. You're left with n over 3n, which is a third. Alternatively, you can look at this. As n tends to infinity, that will disappear, and you're left with a third times 1. Either way, you get the answer of a third. Okay, so that the infinity question can come up sometimes. Okay. Harder question then. This can, in theory, come up in an exam setting. This is a situation where it's not f of r minus f of r plus 1. It's a more complicated cancellation pattern. So if you have a question like this, you need to just draw out all the terms and try and spot the cancellation pattern. It's good to work in columns. Okay, you'll notice that when I've done the previous question, I've put all the denominators of 1 in one column, 4 in another, 7 in another, 10 in another. So all the denominators are in their columns, so it's easy to see the cancellation pattern. Another good technique to use for these ones is don't try and simplify the fractions. So if you have 3/9, leave it as 3/9. Don't change it to a third, because you want the ninths to cancel with other ninths. So it's best to leave it exactly as it comes from the series. Okay, so crack on. Plug in R is 1. Okay, this time it's R is 1. That's my base. So when R is 1, I'll get 2/7 minus 3/4 plus 1/1. I get the feeling this is going the wrong way around. So what I'm actually going to do is just write that the other way around. I'm going to say those two fractions are backwards, because I expect the denominators to go up by 3 each time, not down by 3. So I'm not going to do that. I'm instead going to say 1/1 minus 3/4 plus 2/7. And now plug in R is 2, I'll get plus 1/4. R is 2, so that's minus 3/7. Plug in R is 2, so that's plus 2/10. Okay, notice I've left it as 2/10, not simplified it to a fifth. Plug in R is 3, I'll get plus 1/7 minus 3/10 plus 2/13. And that should be enough to hopefully spot the pattern. Plug in R is 4, and we'll get plus 1/10 minus 3/13 plus 2/16. And you can see that the advantage of writing it in columns, those 3 will cancel, those 3 will cancel, those 2 will cancel with the next one, and that one will cancel with the next 2. Okay, so it's a more complicated cancellation pattern. Miss a few terms. I'm going to go back as far as n-2 this time at the end of the series. So n-2, I know you can't see it now, but n-2 is 1/3n minus 8 minus 3/3n minus 5 plus 2/3n minus 2. Plug in n-1, I'm going to get plus 1/3n minus 5 minus 3/3n minus 2 plus 2/3n plus 1. And then finally plug in n, and I'll get plus 1/3n minus 2 minus 3/3n plus 1 plus 2/3n plus 4. And we can see that again that those 3 have cancelled, just while I've done the last 3 terms, so we can see the full cancellation at the end. Those 2 will cancel with the one before it, that one will cancel with the 2 before it. So we're left with these 3 terms at the beginning of the series and these 3 terms at the end of the series. So therefore the series is going to be equal to 1 plus 1/4 minus 3/4 is 3/2. And then 2 of those minus 3 of those is minus 1 of those. And then that one there. Again, you might have a question which is, as n tends to infinity, what does the series tend towards? Well, that's going to go to 0, that's going to go to 0, you're left with 3/2. So the series will tend to 1.5. Or you may be asked to leave it as a single fraction, in which case we'd have to do some major cross multiplying here to get a single denominator across the 3. But again, that's nothing too taxing. All right, thank you very much.